Hi everyone, I'm Alastair, one of the task organizers for this task alongside Hendrik and Dmitry and Julián. So we're calling it the AcousticBrainz Genre Task, specifically working on content-based music genre recognition. So we're talking about music information retrieval, which is a relatively large field that deals with analyzing many different aspects of music. I mean, we look at things like what Apple and what Spotify do with this sort of presenting music to people, doing recommendations, and understanding music. So we're looking at a subsection of this called genre recognition, and specifically content-based genre recognition. So the question of being given a piece of audio as an input with no extra information and being asked to say that I think this is jazz, or I think this is 20th century classical, or I think this is hip-hop, for example. It's a really popular task, but what we find a lot of the time is that people do these tasks over a very small number of genres. So we're looking at maybe 10 classes. People saying, well, it's rock, pop, jazz, classical, folk, country, perhaps. And so these are relatively broad definitions and also very Western popular centric, so the kind of things that you might expect to see on the top 40 here in Europe or in the US. We find that there are not many studies that work on more specific types of genres, so perhaps within hip-hop you might be talking about West Coast hip-hop, so something specifically from a particular part of the US, or region-specific, or more specific definitions, say, in jazz, if you're looking at early jazz, or bebop, or smooth jazz, or contemporary jazz, sort of any of those specific differences within a particular style. We also find that, genre itself is very subjective. You ask lots of people what they think the genre of a particular piece of music is, and you get lots of different answers. And they look at this as a single classification problem. So we say, well, what genre is it? We believe that it can only be one genre, and that's not necessarily the case either. We see that there's a lot of music that can be quite correctly classified into multiple different genres. And these data sets are very small, so we look at people presenting data of maybe 1,000 samples as a training set, so 100 examples in 10 different classes. So how can we do this differently? Well, we work on a project called AcousticBrainz, which is a community database of music features extracted from audio. And so this is open data that's available for anybody to download, and it's built on submissions by the community. So we give software to people that they can download, run on audio that they have, and they submit these specific audio features back to us. So this is spectral-based, frequency-based information, things like spectrograms. We calculate spectrograms, we calculate MFCCs, for example, and so we store all of this data. We have over 10 million submissions from the community, and so we have all of this information that we can use for machine learning tasks. All of the data in AcousticBrainz is connected to MusicBrainz, which allows us to look up additional metadata if we wanted to. And so we collected all this data and we said, well, what can we do with it? And so last year we launched for the first time this task with a goal to predict the genre and subgenre of unknown music recordings given these music features from AcousticBrainz. Why is this task different? Because it's bigger than many tasks of the same type of style that have been done before. So we have genre annotations from 4 different distinct sources. We've got hundreds of specific subgenres instead of 10 broad genres. We're treating it as a multi-label classification problem, so we're saying that perhaps the correct answer could be one of a number of labels or many labels at the same time. And we're providing a very large data set, so instead of just a few thousand training samples, we're giving over 2 million training samples. So where do we get this data from? We're scraping this data from the internet from a number of different sources. 2 of the sources are more editorial websites. So one is Discogs and one is AllMusic. They have explicit genre hierarchies. So here's an example from AllMusic, which has blues and a number of subgenres of blues and a number of styles within those subgenres. We have annotations at a album level for all music, so saying this album is in this particular genre. And there's a fixed taxonomy here. We have two other sources of information, one from Tugtrum, which is some software developed by Hendrik here, and also from Last.fm, where we have folksonomy tags. So this is where people can type in any descriptive text to describe these tracks, and we have a whitelist that we look at these tags, and we say, well, this tag looks like a genre, so we're going to take that as an application, as a label for that particular track. We do some tag cleaning, which is described in our overview paper, and we infer genre and subgenre relationships between those tags. So here's a question: what does this data look like? We have a video. Just listen to this track and think about what you think the genre of this may be. This is the exactly. So if you know the answer from last year, okay. Any people want to make a guess at what the genre might be? Dub. Anyone else? Okay, so it's dub. Great, question solved. So that's we don't have to do this. Don't have to do the project anymore. So if we go to All Music and we ask what the genre is, it says that it's electronic, in fact. It does specify a couple of substyles. It's world fusion and it's ambient dub, so very specific. It's a subset, it's a subtype of dub. But we continue. We could say, well, what does Discogs say? Well, Discogs says it's reggae. So, I mean, now we've got two different sources. What happens if we keep going? We can ask Last.fm, what have people tagged it as? World. That's great. That's that sort of catch-all, everything that isn't rock and pop. It's got some geographic tags as well. So it says it's Ethiopian, it's ethnic, it's a fusion, so it's multiple genres, but fusion of what? We're not really sure. It does have dub as a tag there as well. So we're looking at this idea of subjectivity in genres. So we know that we can ask many people the same question. We can come up with a different answer. We find a lot of the time these classification tasks typically have a fixed one correct answer that they're expecting people to come up with a solution for. And so we've got this question of, well, if we can't find agreement in the ground truth, if we can't find agreement from multiple different people labeling it, what should the response of these machines be in giving us an answer in a classification task? We're also finding things like, well, what happens if different sources use a different label to refer to the same thing? Or what if different sources use a label which is spelt the same, the word is the same, but the meaning, the definition within that community is different? And so this is why we pulled together this data set with two subtasks. So as I said, we collected ground truth from 4 different sources. And so we presented 2 subtasks in this challenge. The first subtask is to do training and classification within a single source. So take, for example, one of the examples we showed, All Music. So take ground truth from All Music and build a classifier that can classify tracks for which we have annotations in the test set from All Music. The second subtask that we looked at is we wanted to see, well, what happens if we give people all of these annotations from many different sources? Can we build some sort of hybrid classifier, some classifier that uses ground truth from many different sources and builds a single classifier that we can use to predict the genre, the label of tracks from any test set from any of these other, any of these data sources? So what did we build? Well, we built 4 development, testing, and validation sets. So that is one for each of the data sources. with 70% in development and 30% reserved for the testing and validation sets. We provided an album filter, which is something that we typically do in music information retrieval. The idea here is that we don't want to overfit, for example, in a single album or music by a single performer. So we don't want to say that we're actually training for a particular performer or a particular album. We ensure that we have a good number of recordings for each example, so each label has at least 40 recordings available from at least six different albums. That's a little bit smaller in the testing and validation datasets because they have fewer recordings in them. And so we ended up with 1.3 million recordings with annotations from all music, a little bit less, 500,000 for Alastair and Tagtraum. This is not entirely overlapping, so we have less than 500,000 tracks which are annotated by more than one source, and quite a few less, about 200 to 300,000, that are annotated by all four sources at the same time. And we also see that we've got a varying number of genre and subgenre labels. So for example, all music, we have 21 genres and 700 subgenres, but in Discogs and Last.fm and Tagtraum, the number of genres and subgenres are a little bit smaller. But we see that we have multiple annotations for single recordings, and we see that the number of genres and subgenres is significantly larger than the typical number that we work with in other types of evaluations in this field. So a bit of task history. We, as I said, we ran this for the first time last year. This year we're presented two for the evaluation last year we had two baselines, one which was a random baseline, just based on the distribution of the labels that we had in the data set, and a popularity baseline which always predicted the most popular genre in the data set. We had 5 submissions, 5 teams submitting last year, with a number of different methods, so neural networks, support vector machines, random forest, so about 100 runs last year. This year we are presenting 2 deep learning baselines. One thing that we did is that we withheld data from last year's challenge that wasn't used, and so we had a training data set and an evaluation data set from last year, and the evaluation data set from last year is now public, and so we distribute that as a test set, so we have this ongoing baseline that anybody who wants to participate in the challenge in the future can evaluate against the public results from all years of the challenge. And so we've got this this private holdout validation set that we keep ourselves for any future tasks. As I said, and this year we have 2 baselines which we will be presenting shortly. Do you want to jump in on evaluation? Julián's going to spend a couple of minutes talking about how we're doing the evaluation for this task. Thanks, Julián.
All right. Yeah, hello again. So evaluation. So what we have is essentially multi-level classification with a hierarchy. And if you look in the literature, there are certain metrics to take into account the hierarchy when you score the systems. But in the end, we decided just to keep it simple because those metrics might not be so clear to understand and really know what the numbers mean. And in the end, we only have 2 levels in the hierarchy, genre and subgenre. So let's keep it simple, evaluate at different levels. And then after 1, 2, maybe 3 years, we start looking with more detail into the data. So we use basic stuff, precision recall and F-score. And we have like 2 sets of results. One is looking at all the recordings and then evaluate considering all the labels, only the genres or only the subgenres, and we get the scores. The other side of the picture is we look at the labels and compute precision recall F-score based on all the labels or all the genre labels or all the subgenre labels. So we have many different scores, many different numbers. Just to say, as an example, here's a confusion matrix for the tactron dataset, and this is the random baseline. And as you can see, well, it's random, right? But still, we can see some dark places around here with the most popular ones, which are rock, pop, and typically those. But it's basically random, right? This one here is one of the best submissions that we had last year from JKU. And of course, you can see still the popularity problem in here, but a nice diagonal, right? So they actually build a system that is learning to correctly classify the genres. Looks nice, but if you look into the subgenres, well, it's a little like a static noise, right? Here we have the random baseline. Again, we see certain bands of colors, right? Popular subgenres. And in this is the same submission. Looking at the subgenres, we see a few lines, few clusters, but in general, we can see the diagonal. So they are still learning the diagonal. And still remember that here we have hundreds of different labels. So that's actually a good job. Little bit more detail. Here we are plotting all the results from last year. And as Alastair said, that test set from last year, this year is public. So we also run the systems from this year on last year's results to compare everything from the two editions. So we have every column is a different data set. On the top we have only the per genre labels, and on the bottom we have the only subgenre labels. And what we see is, well, first the subgenres are a lot harder to classify. These vertical lines here are the two random and popular baselines that we have. So you see when you look at the subgenres, it's a really complicated task. When you look at the genres, well, just by randomly choosing a label, you can do fairly well. But in general, what we saw is that, I don't know if you can see the colors, but this purple one here is JKU. Those were the best systems from last year, and of course, still this year. And I want to mention two in particular, or three. So the pink one is a male baseline that Hendrik is going to present later, and the dark blue one is the fusion baseline that Dmitry is going to present later. And they are clustered around here, there, right? So you see that they're a little bit worse than the best systems that we had last year, but still doing fairly well compared to the other systems that we had participated in actually last year. Something that I want to mention is the number indicates the task. So it was a system for task 1 or task 2. And in general, we see that whether it was task 1 or task 2 didn't make any difference. Basically, the systems were performing the same, except for the fusion baseline that we have this year, the dark one. Would you see the task 1 in here, task 2 in there? Task 1, task 2, 1, 2. So it's actually improving the precision in this case. But in general, this is the kind of results that we have. And again, it's over 130 different points aggregated in those plots. So then we run into this kind of problem last year that didn't turn out to be a problem in the end. So we didn't explicitly ask the participants to predict the genres when you predict a subgenre. So I could say this is Delta blues, this is a subgenre, but I'm not predicting explicitly the genre, which is blues. So we thought, well, but maybe you should. You are implicitly predicting the genre, right? So what happens if we implicitly assume that you are predicting it and evaluate again? What would happen? And we're going to see. Yeah, what I said. And what we have here is same, again, genres. We have precision, recall, F-scores. And what we have is here the results that we just saw before without expansion. And in the y-axis, we have the results that we have with expansion. And you see that everything is basically the same, except for two, which are, again, dark blue fusion baseline from this year from Dmitry, which is these points. We got a worse performance in terms of precision, right? It got better in terms of recall because we are explicitly predicting a new genre. So it's improving recall, but it's making precision worse. And the other one, XE, which is the green one, which is in the same situation. Funny thing about the one by Dmitry, for instance, is that it's actually using the hierarchy. One of the problems that we had is that most of the participants did not care about the hierarchy. They just made everything flat and predict. And we only have 2 submissions that did it. One of them, you did more or less.
That was the BIS.
Yeah, the green, the red one. What they did last year, the red one, they built classifiers for the genera, and then within each genre, they built another classifier for the subgenres. So they go in kind of 2 steps. So this is what we have, and you're going back to the conclusions. Yeah. Or you, or yeah.
So. How should I do it? Oh, really? Okay. So yes. So the conclusion, the main conclusion was actually already last year that the task was really difficult. And I would also say that the first problem to address in this task is actually people have to cope with all the amount of data that we provided. So these are millions of recordings. So I think that was kind of breaking a bit some people were getting lost in just processing too big amounts of data. And the best system from last year, as we saw, it was training for a long time, the neural network, and basically they had the architecture to be able to do that, while some other participants were kind of limited in their resources and they couldn't do just as well. Then our datasets were very unbalanced, and that could also affect making it even more problematic. Yeah, the most difficult dataset was the all music one, because it contained 700 subgenres, so it's kind of crazy. Yeah, there was proposed some number of approaches that explored either standard approaches or deep learning, but they did not explore in details the possibility of hierarchies or the possibilities of merging together all sources and taking advantage of that. At least we haven't seen the improvement. The best system so far is the one from the last year done by JQ. And now this year we present 2 baselines that are relatively simple, that much more simple than the submission by JQ last year, and they're somewhat worse, but they're comparable to the second best submission from last year. I think that what we got so far, so in fact we are doing all that because we are kind of running this AcousticBrainz thing. This is a project where we gather information about music, and this is an ongoing project that develops, and it is changing over time. And the idea was that we can integrate the best submissions into that project and then have like a feedback loop from the users of AcousticBrainz that would allow us to reshape this problem. There will be a number of updates in the AcousticBrainz plan this year, for example, that I think will expand the interest of this task. So there was a low interest this year. So basically this year we got 4 participants registered, but then finally we ended up with nobody participating, and we instead prepared these 2 submissions. We consider there is a number of reasons for that. And I think, well, in my opinion, the main limitation of the data that we provide for MIR research, so research in music, is that for now it is summarized by the frames are summarized, so we don't have the temporal evolution information. And many people just want to do deep learning, and they want to do it on time frame data. And this is the type of data that AcousticBrainz will include this year. So, but we will kind of start gathering new submissions in our system, users analyzing their personal music collections, and then hopefully we can gather enough data to kind of reshape this task in the future. Another option is basically to also prepare other data sets, maybe simplifying some of those that we have, or even just pre-processing the data in the form that's just easily consumable, that people just can start working right ahead, because right now it's more like you need to do a bit of web, you need to, well, parse JSON files, like pre-process them, you need to learn the metadata structure, etc. And of course, I think that what we saw that there was not much participation from our community, from music information retrieval community this year, because the people that did that last year, they kind of moved on to something else. And the main task for us will be to actually push that into the main conference in our area, because as we feel basically we have a conference called ISMIR, and if you don't publish there, you are you don't exist in our community. Like what you do is kind of ignored. So I think in 2 years now, we have a pretty decent amount of stuff that we can just put together, have a nice publication and promotion there. We already started this ISMIR. We got some interest of some companies, for example, working on this task, like Deezer in France. Yeah, and then that will help the task, I think, enormously. So yeah, that's the end of the overview. So